Hello and welcome to our lesson on special cases of the law of sines. So in our previous topic we saw where the law of sines was coming from. We also saw how we could use it to solve triangles given an angle, angle, and side guarantee, or triangles that were determined by angle, side, angle. And I sort of mentioned that those would be the only two cases for which we would use the law of sines, but it's not entirely true. We can try to solve an oblique triangle given side-side angle. Now remember, there is no, that's my highlighter, there is no side-side angle congruence theorem. So when we're given a side, and angle, we are not guaranteed a triangle because there's no congruence theorem. There's no guarantee that if we do the solving that we are ending up with a unique triangle. In fact, we can still try to solve, okay, when we use the law of sines to try and solve a side-side angle, it may be the case that we end up with a situation that's impossible to solve. So sometimes it just isn't going to happen. And so I'm going to show you when that's going to occur and what to look for there. And it may also be the case that there are two different triangles that could be formed. And we call that the ambiguous case because it's not exactly clear what our missing information is supposed to be. So it's sometimes the case that it's just impossible since side-side angle doesn't guarantee anything. We don't even necessarily have a triangle, and sometimes it may be ambiguous because there are going to be multiple options for the information that we solve for. Okay, so I have over here as reference our law of sines formulas. Remember, we're only going to use two ratios at a time, and we can put the sines of the angles on the top and then sides on the bottom, or vice versa, whatever you feel like is going to work better for the situation that you're in. Yeah, so it doesn't matter. They're going to be equivalent. Okay, so let's try and see an example of when this is going to be impossible and why that happens, and then we'll look at the ambiguous case and again why that's going to happen. So let's start with this first problem. Okay, we are asked to solve triangle ABC. We're given that angle A is 60 degrees, A is 4 centimeters, B is 14 centimeters. So just like we did in the past. Let's draw this out. Remember, it doesn't really matter what your triangle looks like. These things don't have to be to scale or anything. We just need some place to properly label the information that's given. And so I'm going to call this, turn this off, angle A, and I'm going to call this angle B, and we'll call this angle C. So it says A is 60 degrees. I'm going to label that. It says side A is 4 centimeters, so I'll put that in, and then side B across from angle B is going to be 14 centimeters, so there's the information. And now you can see we have two sides given, and we have an angle given, but that angle is not between the sides. So I have a side, and then an angle that is not included. So a side, and then an angle. This is side, angle. This is the case, okay? Not guaranteed to be a triangle, and in fact this one's not going to end up being a triangle at all. But let's just say we wanted to try to solve. If I wanted to find the missing side, I don't want to do that actually. Let's say I want to find, I don't want to do the missing side. Let me back up because you're probably wondering, well, why not? Remember, Pythagorean theorem is not going to be an option because this isn't a right triangle. But in our ratios, whichever ratio I go to set up, so let's say, oh my gosh, my pen. Okay, so let's say I wanted, don't write this down if you're taking notes, I wanted to find side C first. So maybe I use a ratio that has C and then the sign of C. Well, I don't know C yet, so that's two unknowns in my picture, which is no good. Oh, I'm sorry, I'm having issues here. Okay, so I can't find C first because that would make two unknowns. So let's start by finding one of the missing angles, and I'm just going to arbitrarily choose to try to find angle B. So if I want to use angle B, again, I want to use a ratio that includes angle B. So I would say the sine of angle B over its opposite side, which is going to be 14. That has to equal another ratio of a sine of an angle with its opposite side. Now, since I'm given angle A, that's the angle I'm going to use. So I'll say sine of angle A, which is 60 degrees, over its opposite side, which is 4. And just like yesterday, we can use our inverse operations to solve. So the sine of b is being divided by 14. My first step would be to multiply both sides by 14. And hopefully you can do this without showing the work, but if you multiply by 14 here and multiply by 14 here, this is going to reduce, but I don't care. It's going to end up going to the calculator anyway, so I'm not going to worry about that. But it's going to cancel here. The important thing to know is that the 14 ends up on the top of this fraction, and it cannot be multiplied by the 60, okay? It needs to be multiplied by the sine of 60, because that's not really a 60 there. Again, it's a sine of 60. So if you wanted to skip what I wrote there in pink and just say, okay, my sine of b is going to be equal to 14 times the sine of 60, all divided by 4. Now from this point, a little different from the solving we saw before, we were solving for sides, we haven't yet solved for an angle. How do we solve for angle B if we're looking for the sine of angle B to be equal to that ratio? Well, I have to use inverse sine because that ratio is clearly not going to be on the unit circle. So if I take the inverse sine, B, my pen is slippery, is going to be equal to the inverse sine of this ratio. So 14 sine of 60 over 4. And now it should be a calculator problem. And it's going to be a calculator problem. Let me show you. So if I put in the inverse sine of 14 sine of 60 divided by 4, it says that this is undefined. So why on earth is this undefined? So this is an undefined expression. I tried to put it in the calculator and it was not giving me a value. Now why does that happen? So I want to back up to this step right here. What I'm asking for here is to find the sine of some angle B such that it's equal to this ratio. Well, if I put just that ratio into the calculator without the inverse sine, if I just put the ratio in, then what we end up with is about 3.03. So 3.03, and I should change this. This is, come on, eraser. So the sine of my angle is, we're trying to find an angle such that the sine of our angle is about 3.03. So why does this end up being something that's undefined? Well, we know the maximum value for sine is 1. We know the minimum value for sine is -1. So if our range is from -1 to +1, this is clearly out of the range. So this is not in range here. How many colors can I try to work into this problem? Let's go with, how about gray? So this is not in range for sine, which is why this ended up being undefined, because this is not in the domain for its inverse. Right? That's why we ended up with something that's undefined. So if it's not possible for us to find an angle B such that the sine of that angle B is going to be equal to about 3.03. It's going to be impossible to make a triangle that has these characteristics. So the fact that this doesn't work out for us is telling us, well, one, we got to be careful. Like we don't want to just make an error in our work and say, oh, this is an impossible triangle. But we are specifically getting a value that's not in the range of sine, or we're trying to find the inverse sine of something that's not in the domain for that inverse. We end up with something undefined. This is an impossible thing to try to solve. There is no such triangle that has these given characteristics. And it wasn't guaranteed, so it should make sense that that was a possibility. So this is impossible to solve. We can say that there's no solution or that there's no such triangle. There are lots of different ways to answer this. So there is no solving, there is no solution, there is no such triangle existing. Okay, so lots of ways to answer that. But the key takeaway from this, again, we need to remember that the range for our sine wave, our sine function, is from -1 to +1. So if we're trying to find an angle such that the angle produces an output that is out of that range, right? If you're trying to find an angle and its ratio for sine, so in this ratio for sine, which ended up being our 3.03, if that is outside of its range, either above it, greater than it, or below it, less than it, then no such angle exists. And the result is a case, a problem, that is impossible to solve. And that would be nice, because then your work just stops. Okay? So we have, with side-side angle, the possibility of this not working out, of the information being given not even creating a triangle. And then we have the trickier case, what we're going to see here, and just looking at the notes you can see how there's so much more space. Yeah, this is going to be a trickier one here. So again, we're asked to solve a triangle. Just by looking, maybe we don't see anything different happening with this problem, so we start the same way. Well, we draw this out, and we make our triangle. That was terrible, but my lovely technology fixes my terrible triangle. So we have triangle A, B, and C, and this one they give me angle A as 40 degrees, side A as 54 inches, and then side C as 62 inches. Again, looking at the information, I have a side, I have a side, I have an angle, and that angle is not between those sides, so I have side, side, angle. So not a guaranteed triangle, but this one won't be impossible. What we're going to see is some ambiguity in this problem. So let's say, again, I can't start this by trying to find side length B. If I wanted to, I could say B over the sine of B would be my first ratio. That's an unknown. That's an unknown. So I'm not going to start there. I'm going to have to start by finding one of my angles. So let's say, what did I find B in the last one? Let's say I go to find C, and I'm just choosing C. It really doesn't matter which angle you start with, okay? So if I wanted to find C, then maybe I write a ratio that says I guess I have to this is silly. So I said I can't find B because I didn't know angle B. I also can't, this one was different. Yeah. I also can't find angle B because I don't know side B. So I have to find side or angle C in this one. Just silliness. Okay, so let's do it. If I want to find angle C, again, I want to write a ratio that has the sine of angle C over the side C, which we know is 62. And that's going to be equal to another ratio. I don't know anything about B, so I'm going to use A. I'm going to say the sine of 40 over its opposite side, which is 54. And now sine of C is being divided by 62, so I multiply that over. Again, it's going to end up on the top of my fraction. Actually, it's going to end up right there in front. And so I can say that the sine of C is 62 times the sine of 40, not to forget my degrees, over 54. And before I continue, I'm going to go ahead and put that ratio in and make sure it's in the range. So 62 times the sine of 40, and that's all going to be divided by 54. And you see that's approximately 7 or 0.74-ish, which is in our range from -1 to 1. So this is not going to be an impossible situation. It's possible, but something different is going to happen. So as we continue this, if I wanted to solve for C, I have to undo the sign, and I do that with inverse sine. So C is going to be found with our calculator by taking the inverse sine of this ratio. So 62 sine of 40 again over 54. And then we're going to get an approximation for C. So now I go back to my calculator, and I already typed this in, so let me just move my cursor to the front and say, hey, find the inverse sine of that thing. And make sure again that your calculator is in degree mode, not radian mode. Okay? So it says our angle is going to be about, let's call this 47.6 degrees. Alright, now small problem, and you might not be thinking there's a problem here at all, but when we go to make this calculation for the inverse sine, when we evaluate inverse sine, remember it's restricted. The range of angles for inverse sine goes from negative pi over 2 to positive pi over 2. So we're only going to find the sine of angle C being equal to this positive ratio in quadrant 1. Now that's because the inverse sine is restricted, but we're not actually trying to find the inverse sine. I use the inverse sine as an operation to solve. What we're trying to find is an angle such that the sine of that angle is a positive, whatever that ratio is. And sine happens to be positive in two quadrants. So sine is positive in two places. Okay? Sine is positive in quadrant 1 and in quadrant 2. So in quadrant 1, right now we're looking at this 47.6 degree angle. And if I made a triangle out of this, in quadrant 2, I could reflect that. That's a little kind of a bad picture, but I could reflect this triangle over into quadrant 2 and put a 47.6 degree angle here. And the coordinates here would be the same as the coordinates here, specifically the y value, right? So I have a positive x value and I have a y value. Here I would have a negative x value, but the same exact y value. Remember, those y values are our sines. So the sines are going to be the same at both of those angles, in quadrant 1 and quadrant 2. So there's some ambiguity here. Am I talking about the 47.6 degree angle? Or am I talking that's in quadrant 1, or am I talking about the angle that starts here and doesn't end in quadrant 1 but ends here instead? Okay, so I have two options. I could say that my angle is the 47.6 degree angle that's in quadrant 1, or I could say C is approximately how much? How would we find the measure of that angle that I've highlighted in green? Well, it doesn't go all the way to the 180 degrees. It is 47.6 degrees short. So I could say that it is, put my pen back on, 180 degrees minus the 47.6 degrees. So that would make it approximately, I'm not going to try to subtract and mess that up, minus 47.6. It's approximately 132.4 degrees. Okay, so again, because we are looking for the sine of an angle. So back up to this step right here. I know that we took the inverse sine, but we only did that as a process for solving. That's really not what we're evaluating. We're trying to find an angle such that the sine of our angle is some positive ratio, and that happens in quadrant 1 and quadrant 2. The calculator is only giving us the value from quadrant 1. We have to find the value in quadrant 2, and we will always be able to do that by subtracting the value the calculator gives us from 180. So the angle in quadrant 1 will be supplementary to the angle that's in quadrant 2. Okay? So what this means, because we have two possibilities for angle C, it means we have two possible triangles that could have the measurements that were given. So in these ambiguous cases, we have to solve for both triangles. Okay? So we're going to call this one case 1. And let me get a highlighter color. Nope, I already used green. I'm going to call this case 1. So I will solve the rest of the triangle saying that C is 47.6 degrees. And then I'm going to call this one case 2. Case 2 is going to be, well, C is not in quadrant 1. It's not 47.6 degrees. It's not the acute version of our oblique triangle. It's 132.4 degrees. It's the obtuse version of our oblique triangle. So let's do case 1. And I'll label it that way as well. So case 1. Okay, corresponding with C being approximately 47.6 degrees. Now remember, we're using the same triangle we started with, okay? So I know that C is 47.6 degrees. A hasn't changed, it's 40 degrees. So the missing angle now, I'm going to subtract from 180 the two that I know. So I take 180, subtract out the 40 degrees we had for angle A, and subtract out the 47.6 degrees I'm saying that we're going to use for angle C. So if I subtract both of those, I'm left with, not 10, geez, 92.4 degrees. So this means B is going to be approximately 92.4 degrees. So in case 1, angle C is this, angle B is what's left from 180, and then the only missing piece from here would be side B. So I already have side A side C, right? I've found all three of the angles. Now I just need side B. So I'm going to say that the side B that I'm looking for over the sine of angle B, now I'm forced to use this approximation, 92.4 degrees, is going to be equal to the next ratio I use. I don't have to do any rounding because I can use the sine of A with side A. So sine of A with side A. Side A was, I forgot, 54. And then sine of A, which was 40 degrees. So to solve for B, it's being divided. I just need to multiply. Again, multiplying both sides by the sine of 92.4 is going to land that on the top of this fraction. So B is going to be equal to exactly 54 times the sine of 92.4 degrees divided by the sine of 40 degrees. That's my exact answer. And then I go to the calculator to get an approximation. So I have 54 times the sine of 92.4 divided by the sine of 40. And that tells me that B, for this case, is going to be approximately 83.94. And the units for the side lengths here were inches. Okay, so case 1 is that C is the acute angle, B is what's left over from the 180 degrees, and side B is about 83.94. Now we are going to find case 2. And let me use, how about green? So for case 2, again, that's using C at 132.4. So again, case 2, C is going to be approximately 132.4 degrees. And so B is the leftover. Again, B, the last angle in our triangle, would be 180 minus the 40 minus the 132.4. There's not going to be a whole lot left. Let me go back up here. Just recycle some of this. Minus 40 minus 132.4. That leaves only 7.6 degrees left for angle B. And that's fine. Okay, so in case 2, we have angle C, we have angle B, so now we have all three of the angles, and we were given the two sides. We just need to find the third side. So again, the third side would be side B. Side B over the sine of angle B, which this time is 7.6 degrees, has to be equal to, again, let's use A, because that information was given and not approximated. So just like the last one, we're going to multiply by the sine of 7.6. So it's 54 times the sine of 7.6 on the top of the fraction, and divided by the sine of 40 on the bottom. And that's our exact answer. We go to the calculator to get an approximation. And most of this looks the same as what we just did. All we have to do, in fact, is change the angle, change the 92.4 degrees to 7.6 degrees. And that means in this case, B is going to be about 11.11 inches. And we did it. So in the impossible case, it's kind of nice. If we get something out of range, it's impossible. We don't have to continue doing work. In this case, we have the ambiguity of the sine of our angle being either in quadrant 1 or quadrant 2. So we have two possibilities for that angle, and then therefore two different cases we have to solve for. So this is a triangle. A triangle can be formed by the information that was given in this problem, but it can be formed in one of the two ways that we showed. Okay? So in these, we have to remember that the sine of an angle, did I use red up here? Yeah. The sine of an angle is positive in quadrants 1 and 2. And if we are using a calculator, if our calculator, oh gosh, can you hear my dog? If we're using a calculator to approximate the inverse sine of a ratio, that calculator is only going to produce the positive angle that's in quadrant 1. So we have to do the work to produce the angle that's in quadrant 2, but as we saw in the diagram here, when we are looking at those two angles, which are formed by the same triangle, right? The one in quadrant 2 will be supplementary to the one in quadrant 1. So the angle in quadrant 2 is supplementary to the angle in quadrant 1. Okay, so the angle in quadrant 1 will always, or the angle in quadrant 2 will always be its supplement. And supplementary means they add up to 180. So they add, or basically, if they're adding to 180, you're going to subtract the 1 from 180 to figure out what's left for the other option. Okay? So hopefully that makes sense. At this point, I have nothing new to show in this lesson, but I do have 2 more examples just to work through the process again. I would say if you feel like you understand, then feel free to turn the video off, but I'm going to go through 2 more just to be safe. So here's another example, or if you just want to pause the video and try this out and see if you come up with the same thing, that would be a good idea. And you could hopefully see from the 2 examples here that one's not going to work and one's going to work twice. Alright, so here we go. We are asked to solve triangle ABC, and we're given an angle in degrees and minutes. Fun times, right? Maybe I'm going to take care of that first. Let's go ahead and change this 55 degrees plus 40 minutes is 40 out of 60 minutes in the degree, so this is going to be approximately, well, 40 over 60, that's 2/3, so 0.6 repeating. So let's just call it 55.66, let's call it 0.7 degrees, since we're going to end up doing some calculator work with that. Okay, so one little pre-step in this one. So I'm going to draw my triangle. Remember, draw your triangle however you want, however makes you happy, and if no ways make you happy, then just deal with it. Okay, so I'm going to call this angle A, angle B, angle C. In this case, we know angle B is exactly 55 degrees 40 minutes. We know side B is 8.94 meters, and then side A is 25.1 meters. So again, I can see in my picture I have a side, and then I have this angle that is not between them, a side-side angle, so this is not guaranteed. Since it's not guaranteed, it's either going to be an impossible case or it's going to be an ambiguous case. So, how do we do the work, or how do we proceed to do work to solve here? If I wanted to try to find side C first, I could not, because my ratio has C and the sine of C, and I know neither one of those pieces. So I can't go there. Can't find side C, can't find angle C, which means I'm going to start by finding angle A. So if I want to find angle A, the sine of angle A over its corresponding side, which would be 25.1, is going to be equal to any other ratio. Again, we don't know anything about C, so we'll use B. It would be equal to the sine of B, which is about 55.7 degrees, and maybe let's not. Let's try to keep this exact. So I'm going to put in 50. Well, when I put this in the calculator, I'm going to keep it exact, but just to make the writing process go a little faster, I'll write it as 55.7, but again, when I go to the calculator, I don't want to round that and make, too many rounding errors here, so I'm going to use 55.7 here, but put the exact in the calculator. So there's the angle, and then the side opposite A is B this time, is 8.94. Alright, so for the sine of A, I'm going to multiply over the 25.1. So sine of A is going to be equal to 25.1 times the sine of about 55.7, and that's going to be divided by 8.94. Now, this is the point where I want to make sure that this value is going to be in my range. If it is, then I continue. If it's not, then I don't have to continue to do anything else. So I have a fraction on the top, 25.1 times the sine of 55 degrees plus 40/60ths of a degree, and then on the bottom 8.94, and we end up with 2.31. So this means we are trying to find the sine of an angle that is approximately equal to, what did I say, 2.32, and that is not possible. Since that is not in the range, right, that is not in the range of sine, if I went to try to solve with my inverse sine, I would have something that's not in the domain, which would make the whole expression undefined. Since it is not possible to take the sine of an angle and get 2.32, it is not possible for the measurements given to create a triangle. So we will say this is a no solution case, or that it is no such triangle exists, impossible to make a triangle with those measurements, however you want to say it. Okay, no such triangle. And sometimes I will write instead of writing the word triangle, I'll just draw a little triangle there. So if you want to shortcut like that way, that would be fine. All right, the fun one. Next, we're trying to solve this, and we have an angle, we have a side, or side, angle once we put it in the picture. Let's try this out. Again, if you want to pause the video and see if you can work some of this out for yourself, or maybe let's set it up and then you can work through. So here's A, here's B, here's C. We got 55.3 degrees here, and then we have 24.9 feet here, and 22.8 feet here. So again, solving for C in this one, no good. Don't know angle C, don't know side C, so that's the one that we're going to leave alone for a minute. So I'm going to try to solve for angle B. And so if I'm solving for angle B, again, I would say that the sine of B over its opposite side, which is 24.9, is going to be equal to the sine of A, 55.3, over its opposite side, which is 22.8. I'm going to multiply over the 24.9. So the sine of B is going to be 24.9 times the sine of 55.3, all divided by 22.8. Let's make sure that's in range. So 24.9 times the sine of 55.3 divided by 22.8, and we get, 0.89, about 0.90 is definitely in range. So now I want to find the inverse sine to actually get my angle. So inverse sine of the ratio. Can I just draw an arrow? Got that expression in my calculator already. Actually, maybe I should put a down arrow. That should be in there. So I'm going to just put my inverse sine right in front of this. Inverse sine, and then I get my angle. Again, just make sure you're in degree mode, is about 63.9. About 63.9 degrees. Now, remember, we're looking for the sine of some angle to be equal to this positive ratio. The calculator is only giving me the angle that's in quadrant 1, but sine is positive in quadrants 1 and 2. So think about this again. Okay, so you have your angle in quadrant 1, and we're saying the angle is 63.9 degrees. If I drew that over here in quadrant 2, the value for sine is going to be exactly the same. So remember, this is at a point x and y. This is at a point negative x and same y. So the value for sine is the same. Okay? So this is same triangle. This is still 60. Gosh darn, turn my eraser on. Come on. 63.9 here. The angle that's in quadrant 2, remember, we're starting on the positive part of the x-axis and we're landing here. So I have to take the 63.9 away from 180 to get my other option for my angle. So 180 minus the 63.9. 180 minus 63.9 is 116.1. And that's going to be the other option for B. So, or B is approximately 116.1 degrees. So I'm going to call this case 1, and I'm going to call this case 2, and so I have to solve for both options. So let's do it. Alright, so case 1, corresponding with b equal to 63.9, the acute version. So if b is 63.9, then c is the easy part now, right? I know the last angle in the triangle. We just subtract the 2 we know from 180. So it's going to be 0 degrees. 180 minus the 55.3 that was given to us, and now the 63.9 that we have in this case. So we're going to say c is approximately something we're going to get from the calculator. Let's subtract out the 55.3 as well. So we have 60.8 degrees. So I have all three of my angles. Remember, I was given A. I figured out one option for B and then its corresponding value for C. The only piece that's left in our triangle is to find side C. So if I want to find side C, it's going to go over my sine of C, so I am forced to use this approximation. And then we can use any other ratio, but again, I'm going to use A because those two were given. So I will say A, which is 22.8, over the sine of A, which was 55.3. And so multiplying by the sine of 60.8 is going to give me the exact value for C. So 22.8 times the sine of 60.8 degrees in the top of the fraction, and the sine of 55.3 in the bottom of the fraction. And then we go to the calculator to get the approximate value for all that. So 22.8 times the sine of 60.8, and then divided by the sine of 55.3, and we end up with C being approximately 24.21, and this is our feet for case 1. Okay, so this is one option. With the measurements that were given, one option is this is the missing information. The other option is going to be our case 2, which is the same work but corresponding to the obtuse angle. So in case 2, we said we were going to let B be the angle from quadrant 2, which was the 116.1 degrees. So then C is what's left from 180. So 180 minus, again, the given 55.3 minus the 116.1 means that C is going to be, let's see, let's take that out and subtract 116.1. I hope when you are using your calculator that you're also recycling and not having to type things in over and over. So we get 8.6 degrees. So we had one angle given, we found one option for the second angle, and based on that option found the third angle. So the angles are done. Now again, just that last side, C. And I would probably skip some of the work in here too. Myself doing this, if you see the pattern and what's happening, then by all means do that. Otherwise, again, side C over the sine of angle C, which this time is 8.6 degrees, equal to A over the sine of A. And so C is going to be equal to exactly 22.8 times the sine of 8.6 divided by the sine of 55.3. And then we go to the calculator to get that approximation. And again, almost the same thing we have here. We just need to swap out with our new angle. Oops, and I already have my calculator here, so I can just replace the 60.8 with 8.6, which means for this case, C is going to be about 4.15 feet, and we did it. We solved for both cases. So with the side, and angle that was given in this particular case, it does make a triangle. The thing is, the triangle could be one of two things. And so both of those cases are now solved for, and we are good to go. Alright, so hopefully you have enough examples, and enough understanding to work through your practice problems, but as always, if you need extra help, then reach out. Until next time, take care.